Today, our group with me, Zali and my friends, and Jessica, Amir, Afiq, and Nicholas will present about basic facts about addition and thinking strategies to memorize it. So, first, we need to go back to the concept how to understand addition. Generally, addition is taking two or more numbers and adding them together, which brings result in total sum of two or more numbers. And the symbol denotes the addition process, which is called plus or combined rate, and it can be also used multiple times. In a math sentence, for instance, 5 plus 3 equals 8. Uh, 5 and 3 is called the addends, which numbers that are added, and 8 is called the sum, the answer to the addition. And generally, the addition is simply by counting the numbers, where using fingers has become more common for us to learn how to count and add them until 10. We start from counting our fingers to count on until 10. Then it goes on by stages from maybe from our physical to on a paper, like drawing dots on paper. Then we apply using the number line, the drawings, the figures, and the final one we were going to learn addition by introducing those symbols and the digits. Now the next one, uh, is Matt Jessica here?
Okay, yeah. Can everyone hear me? All right.
Yes.
Okay.
Yes.
First, okay, thank you. Today and next is we're gonna see the basic fact of addition. All right. What is the basic fact of addition? First of all, we are gonna see about the characteristic of the basic fact of addition. Okay. First, the basic fact of addition is the sum of two one-digit addends are combined by addition to give a sum. Second, both addends or both factors are less than 10, and the sum of two specific addends will always equal to the same result. Okay? So next we're gonna see the range of the basic fact of addition. The basic fact of addition will start from 0 plus 0 equal to 0 until 9 plus 9 equal to 18. So we're gonna see the correct equation and the false equation. First, we're gonna see the 7 plus 4 equal to 11. We see here that why it is correct, because it is a one-digit addends and both addends or both factors are like 7 and 4 is less than 10. So even even if we change the position 4 plus 7 or 7 plus 4, it will always equal to the same result. It is like 11. So next we're gonna see the false equations of the basic fact of addition. Why it is false? Like 12 plus 4 equal to 16. Why? Because 12 is a two-digit addends and it is more than 10. So it is wrong as in terms of basic fact of addition. All right. Next, why we want to teach the basic fact of addition to the primary students, because committing this basic fact addition to memory will it will speed up math tasks and frees the brain to focus on other math processes. Okay, so next we're gonna see about the basic fact of addition in diagram. Okay, we can see here the diagram is like from the upper um, table, like from the plus until the 9, and the plus until the 9 below. So if we use a ruler from the for example, like from 1 from the upper and the 1 from the side, it will overlap at the 2, like 1 plus 1 equal to 2. And then we try from 7 and 4. Both of them will overlap at the 11. And then even if we change the positions, it will the sum of the specific addends. Here we see will always equal to the same result. So yeah, that's all from me. Thank you.
Okay, the next one we'll be covering is the thinking strategies that can be used for students to help students memorize the basic facts of addition. Okay, so the first one we're going to cover is the counting on strategies. I think we have covered this way before, but in counting on is a strategy where students count on the number of the second addend after the number of the first addend. As we can see, for example, here is 7 plus 2. The first addend is 7 and the second addend is 2. So by using the strategies of counting on, student will count two numbers after 7, which is 8 and then 9. And then the last number they pronounce will be the total of the answer to the question. So using the counting on strategies, we can also use the number line too. We usually use number line in counting on. So in the number line, it applies the similar concept with counting on. And also with number line, student can mark the first position of the first addend on the number line as shown in the picture on the right hand side. And then when they started to mark the position of the first addend, they will start counting on the second addend on the line and then finally mark the final total or the sum of the equation. I think that's it. Moving on.
Okay, thank you, Nicholas. Next, we will take a look at the third thinking strategy, which is the finding the 10 or reach to 10. Instead of adding any two numbers as they are, encourage students to add them up to 10 first and then add the remainder to that 10. For example, the process for 7 plus 5 is we take the first number, 7, and add the remaining numbers needed to reach number 10, which is 3. Then we still need an extra 2 to turn that 3 into 5. So it will be 10 plus 2, which equals to 12. This thinking strategy is easier to teach or understand by using manipulatives. We can use manipulatives to help students learn this skill. Draw two rows of 10 boxes on a sheet of paper, one under the other. Then have students place manipulatives into them to represent the sum. For example, 9 plus 4, the first attempt might look like this. 9 plus 4, when we apply the bridge to 10 thinking strategy, is equals to 10 plus 3. As you can see on the picture, we move the second set of blocks into the first set of blocks until it reaches 10. Then only we continue them on the second set. The second question is 8 plus 6. Just like the first question, we take the second block of set, which is 6, and fill them in the first set of blocks. Then we have 10 with remainder of 4, which makes it easier for students to add. So 10 plus 4 equals to 14. For the last question, 9 plus 8, we only have to move one block because 9 is 1 less than 10. Now we add the remainder, which is 7, to the number 10 and equals to 17. Okay, we will continue to each chat.
Thank you, Ame. So for the next thinking strategies is using doubles and near doubles. So what is doubles? Doubles facts are generally an introductory sets of facts that we want the students to become automatic with. It can be related to so many things around us so the students are unable to identify and detect it easily. So I give the example for the things that around us. So as you can see, fingers and toes, 5 plus 5. So we can see that we have 5 fingers in our left hand and also 5 fingers in our right hand. So we total up, we can get 12 fingers in our body. And same goes to our toes. Next is wheels on a car. So we can see that a car will have two wheels on the front and two wheels on the back, or two wheels on the left and two wheels on the right. So also eggs in a carton, which is 6 plus 6. So basically doubles concept is about when in a question both addends are in the same number. So we can see in the picture, 1 plus 1 is equal to 2, 2 plus 2 is equal to 4, 3 plus 3 is equal to 6, and so on. So by using these double concepts, so the student will easily memorize the answer or the sum for the equation by using the concept of doubles. So students no longer have to think much about the equation in order to solve it and able to say the answer within 1 until 3 seconds. So the student will not thinking too long to solve the equation by when the student learn about the concept of doubles. For example, when the students see the equation 8 plus 8, they should know that it equals to 16 without even stopping to think about it. So that's about doubles. For the next, so for the next is about near doubles. So near doubles is actually it's like a similar like a doubles concept. So when a student have a strong foundations of doubles, will help students to easily understand about the near doubles. So when the student have a strong knowledge about doubles, they actually can use the near doubles by using the concept of doubles. So near doubles involve facts like 4 plus 5. So to solve this fact, the students can think, I know that 4 plus 4 is equal to 8 and one more is 9. So as you can see in the picture, we give the example is 3 plus 3. So the students have already know about the concept of doubles. So they can get the answer, which is 3 plus 3 is equal to 6. But when the question is given about 3 plus 4, so the student will know that 3 plus 3 is equal to 6. But the question tells about 3 plus 4. So they must add one more for the answer, which is 7. So the student will know that 3 plus 4 is equal to 7. So that it's called near doubles. The other example is 8 plus 9. So for this equation, students will know that 8 plus 8 is equal to 16. But for 8 plus 9, the student will think about they must add one more. So the answer will they get about the question is 17. So teaching the doubles and near doubles can be extended into tens and hundreds as well. So when the student have already expert learn about doubles and near doubles, they can actually use it or apply it into the using of tens and hundreds. So for example, we can use the facts 3 plus 3 to solve 30 plus 30, or the facts 6 plus 6 to solve 60 plus 60 is equal to 120. So that's it about doubles and near double. So for the next strategies, Izali.
Okay, thank you for Ishad for the doubles and near doubles. The last two ones are the first, adding 1 and 0. Adding 1 to the number is simply by counting on line 1. And also adding 1 is also known as 1 more than facts. These facts can simply be applied by using the part, and whole concept, where uh, from this is the part 6, and the second part is 1. They can know the 6 plus 1, they will be counting on which is more than 1, and we add it to become 7. The next one is adding 0. When 0 is added to the number, the sum is equal as the same number. And teachers, they can use the drawing of two parts with one empty for students to understand the zero rule. If we perform the digits 3 plus 0, it will become the 3, and plus 4, 4 plus 0 equals to 4. This can be seen if we refer back to the basic facts, is this one. We can note the first ones are the added with 0. It will be the same number as the as from the top ones. The last one is commutative. Commutative, by changing the addends order, the sum given will always be the same, which makes no difference in which the order of two or more numbers added. And this will develop students understand in mental mathematics. Considering it is commutative, switching orders doesn't matter. It will reduce the half of the basic facts of mathematics, which make it easier to remember some of the easier facts, like this one. I cannot explain this by words, or maybe I should present it in my whiteboard. Hold on. Okay. Okay. This is what we call part, and whole. The whole one is at the top, and the part ones are at the bottom. I tried to do a line, but consider it's a line connecting this one. Okay, for example, if we do commutative, for example, 2 plus 3, and the part combined with the part with uh, forming a whole, which is 5. And it doesn't matter if we switch positions, 3 plus 2 is equal to 5. The orders doesn't actually matter, because the whole will be the same. Just like what Mac Jessica says. I think that's all from our group. Thank you.
Anybody got any questions? Okay, I think this group, they presented very well. Everything that you need to know, they have told you, complete with illustrations. So that's very, very well done. So let me just reinforce a little bit, that's all. Okay. Okay, so we look at the addition basic facts first. Okay, so you look at the first table, okay, this first table here. So how many basic facts are there? How many, class?
18.
18. Oh, I think
100.
the wrong. Okay, 1 minute, please. minute, please. Okay, this one. I see. Okay, I took the wrong one just now. Okay, let's just fill it up. Okay, so this is the addition basic facts. So this is 0. This is 0. Okay, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so just now Izali told us that one of the strategies is what was the adding 1 and 0, correct? So these numbers that I've written here, all these numbers you can teach them as adding 0. It's adding 0. 1 plus 0 is 1, 2 plus 0 is 2, 3 plus 0 is 3, 4 plus 0 is 4. 1 plus 0, 1, 2 plus 0, 2. Okay, so these are the facts that we are teaching them. 0 plus 0 is 0, 1 plus 0 is 1, 2 plus 0 is 2, 3 plus 0 is 3. So this row and this column, the first row and first column is the adding 0 strategy. Okay, and then we have the adding 1 strategy. Adding 1 strategy is the next row. 1 plus 1 is 2, 2 plus 1, 3. Okay, correct?
Yes.
So how many facts are there here that I've written down here? How many facts? Anyone? How many facts are there?
100.
No, you can't. You see, these are the facts, you know. This one here. All this is adding 0. How many facts are adding 0? All this row is adding 1. Okay, this whole row is adding 1 facts. So all together that I've highlighted, how many facts have I highlighted?
38.
35.
34, isn't it? I have 20 up here, 22, 24, 26, 28, 30, 32, 34, 36. Correct? "36 facts. Okay, correct? The numbers that I've written, the first 2 rows is 20 facts, correct? First 2 rows, 20 facts, and then 22, 24, 26, 28, 30, 32, 34, 36. That means 36 facts we can teach just by using this strategy, adding 1 and 0. Okay? Adding 1 and 0, okay? And the next strategy is count on. Okay, this is a very useful strategy. This strategy we use when you have one addend. Okay, you have 2 addends for addition. When one addend here, this addend, second addend here, it's either 1 or 2 or 3 or even for 0 we can add. When the numbers are 1, 2, 3, and 0, we can use this count on strategies. That means we can, this row, okay, this row is 2, 4, 5, 6, 7, 8, 10, 11. Here is, okay, and then this way, this This way is okay. That means all these facts that you see here now, or everything that you see here now on this chart, all these facts can be learned using the count on strategy. How many facts are there? How many facts do you see there?
$28.
28. Yeah. Up here we have 40 facts, right? Up here. Here we have 40 facts. How many facts do we have here from here to here? 24 facts, right? 24 plus 40?
64.
64 facts, correct? Can you see that it's 64 facts or not? That means you must count each square that has a number you count. Okay, so there are 64 squares here with a number. Okay, that means until here, all this, okay, from here to here, all these facts, there's 64 facts. All these facts here, we can learn using the count on strategy. Okay, so that means you have like, when you have 5 plus 3, okay, one digit here, one addend here is 3. So we can use the count on. When you have 6 plus 2, straight away think count on. Okay, when you have 7 plus 1, you can use two strategies here. You can use either the count on or you can use adding one strategy. Okay, when you have 9 plus 2, you think of count on, straight away count on. When you're given like 2 plus 9, the child must think 2 plus 9 is also equals to 9 plus 2. Here's where the commutative strategy will come in. So because when we count on, we always count on from the bigger number, not the smaller number, okay? We must always count on from the bigger number. Then only your count on is easy because you just have to count 2. And then you can do it mentally, okay? So 9 means 9, you keep in your mind and you count on 2, 10, 11, okay? If 7 plus 2, 7 you keep in your mind, count on 8, 9, okay? So it's easy to count on. So that's why count on strategies, one of the addend is either 1, 2, 3 or 0. Okay, so we finish with 2 strategies. Okay, so the third strategy is bridge to 10. Bridge to 10. You can call this bridge to 10, or you can call this make 10 or use 10 or making 10. Okay, there are many names for this, but it's always making a combination of 10. Okay, so bridge to 10, you can use this. We have here, okay, let's just complete this first. So this is 8, 9, 10, 11, 12, 13. Okay, so bridge to 10 will be all those strategies from here, okay? Okay, all the strategies in the green highlight, okay? All the strategies in the green highlight, we can learn using bridge to 10, okay? That means any facts when you have like this will be 9 plus 2, 9 plus 2. Okay, so this, they must think like what Amir explained just now, 9 plus 2, so you think it's equals to 10 plus 1 is 11, okay? So 8 plus 3, 7 plus 4, 6 plus 5, okay? 5 plus 6, 5 plus 6, or 6 plus 5 is equals to 10 plus 1. You take the 4 over here and you fill up with the 10. So it becomes 10 plus 1. So all the facts inside the green highlight. How many facts are there inside the green highlight? 33 facts, I think. You count later. So all these facts you can learn using the bridge to 10 method strategy, okay? And then you have one more strategy here using doubles, okay? If you notice, this is doubles, doubles, okay, doubles, you have doubles, 0, 2, 4, 6, 8, 10, 14, 18, okay? This line here, the diagonal, are all doubles numbers, okay? 2 plus 2 is 4, 3 plus 3 is 6, 4 plus 4 is 8. And you can also use this strategy for doubles plus 1. Supposing you have 4 plus 4 is 8. So if you have 4 plus 5, 4 plus 5 is doubles plus 1. 4 plus 4 plus 1, doubles plus 1, or doubles plus 2. Okay, we can use this strategy for doubles, doubles plus 1, doubles plus 2. Okay, so we have doubles, doubles plus 1, doubles plus 2, doubles, doubles plus 1 plus 2. Okay, this is doubles plus 1 plus 2, 1 plus 1 plus 2. So all this can be learned using the doubles strategy. Okay, all this can be learned. Okay, it's also here also, doubles plus 1 plus 2. Okay, this is 5 is 2 plus 2 plus 1. Okay, 2 plus 2, all this 2 here, all this is doubles plus 1 plus 2 strategies, all those in blue. Okay, so this whole chart here, there are 100 facts. Okay, you have 100 facts. The fourth one here is doubles, doubles, and you have doubles plus 1 and doubles plus 2. Okay, so all these 100 facts you can learn, you can teach the students to learn using these strategies. Okay, so we use these strategies to help them to memorize these facts. So all these strategies we only teach them in the beginning. Once they've memorized already, they can throw away the strategies. No need strategies. Why we need them to memorize? Because as I think Jacinta said just now, that all the 100 facts are all single digit addends. Okay, so you must memorize single digit addends if you want to use the standard written method, okay, for 2 digits, 3 digits, and so on. So if you don't memorize, then you're going to do mathematics very slowly. So the child must memorize basic facts. Only these 100 facts need to be memorized. Okay, so if you have a fact like this, 6 plus 2 equals to 8, what strategy is suitable for this? Out of these 4 strategies, what strategy is suitable for this?
Count on.
Yes, count on. There's only one strategy that we can use here, count on. How about if you have 3 plus 2? What strategy is suitable for this?
Count on and near doubles.
Count on and, yes, and doubles. Could be doubles plus 1, because you can think of this as 2 plus 2 plus 1, okay? Or 3 plus 3 minus 1 is also doubles less 1, okay? Okay, so what if you had 5 plus 6 equals to 11? What strategy is suitable here?
Bridge to 10.
Yes, bridge to 10. Okay, so we use all these strategies to teach basic facts. So if you see, look at the chart clearly, all these strategies are enough for them to learn all the 100 basic facts. And the last strategy that you all explained just now was the commutative property. Commutative principle or property. Okay, so you know that 2 plus 3 is equals to 5, and 3 plus 2 is also equals to 5. To teach this, it is good if we have flashcards like this. Okay, in the front you write 2 plus 3 equals to 5. At the back you write 3 plus 2 equals to 5. So you let the child read 2 plus 3 equals to 5, then you switch the card, turn it around. Okay, and they can read 3 plus 2 is equals to 5. Or you can use dots. Okay, just now your friends, they showed all a lot of interesting teaching aids that you can use to teach all these basic facts. Okay, so I just want to show you a few more teaching aids that you can use to teach these basic facts. Okay, so this one here, you can search for Origo. Okay, Origo is a book company that they produce books. I mean, the writers, they wrote a book on all these basic facts. Okay, so if you search for like doubles, plus, and then you put Origo, you will get these pictures. Okay. Okay, so this is one example of a card that you can use to teach doubles. It's actually just a card like this, okay? And you have 5, you can fold this card. So you can teach them, show them 5 first, and then you open the other side. So 5 plus 5, so they must know 5 plus 5 is 10, okay? This is for doubles, okay? If you want to show them, okay, this is doubles plus 1. If you want to show doubles one, first you teach them 4 plus 4 without the red dot. Okay, 4 plus 4. So 4 and 4 is 8. So once they know 4 and 4, then you show them this card. 4 and 1 more. 4 and 4 and 1 more. Okay, so they see, look at the dot, they think of 8 and 1 more. So this is near doubles, doubles plus 1. So we can make this kind of cards to teach in class, okay, to show them, okay. And this like what Amir showed you just now, okay? These are actually called 10 frames, okay? When you have 10 things like that, it's called 10 frames. The frame here is called 10 frames, okay? We usually use 10 frames for bridge to 10, okay? Like this, 9 plus 3, okay? So when the student look at 9 plus 3, we must teach them to think like this, 10 plus 2. 9 plus 3 is actually 10. So they must think 9, there's one more space here. So this one yellow must move into that space to complete the first frame, okay? So 9 plus 3 is 10 plus 2. These are 10 frame cards, which you can make to teach bridge to 10, okay? These are other examples, 7 plus 5 is equals to 10 plus 2. These are all 10 frame cards. This is also 10 frame cards by Origo, okay? It's also 10 frame cards, okay? All these cards can be folded. So you can show one, and you can have one set at the bottom. At the back, you can show the original number here, 9 plus 4, okay? And then on this side, you can show how it moves over, okay? So this is all 10 frames for bridge to 10, okay? And this, oh, this is multiplication, okay? So these are some of the teaching aids or manipulatives that you can use to teach basic facts of addition, okay? Okay, I'm done. Second group, please.
Okay, good evening to Madam Rani and all my friends. Today, my group members Atira, Wong, Wei Wei, and Miao, and I will explain the basic facts of subtraction and thinking strategies for memorizing basic facts of subtraction. Okay, next. Okay, first we will look at the addition tables. We know that in subtraction, the first number we can call it minus, and the second number is subtract hand. When minus subtract the subtract hand, it will give us a number is called difference. Okay, so we can learn the basic facts using this addition table, but just the ways to reading is a little bit different. Okay, for this table, the white part is the minus, and the purple part at the left is the subtract hand, and the and above the table is the difference. So when we want to read using this table, we must read from the white part to the left part of the to the purple part of at the left, and the answer will at above of the tables. Okay, for example, can Atira shows click point a number. Atira point a number on the chart. Okay, for example, Okay, Atira point 0. So when 0 minus the left part is also 0, then it will give us an answer is also 0. Second example, Atira point another. Okay, Atira point the number of 1. When this 1 subtract the left part, the purple part, which is 1 also, then it will give us an answer is 0. Okay, next slide, Atira. Thank you. Okay, this with this table we can come out the 100 basic fact of subtraction. Okay, next. Okay, next we will move to the thinking strategies for memorizing the facts of subtraction. The first strategy is counting back, a method of learning subtraction by counting backwards from the first number in the problems to get the answer. For example, when the first number, which is 9, need to minus with 2, we can counting back 2 steps to get the answer. The difference 7. Example 2, when the number 7 subtract by 3, we need to counting back 3 steps to get the answer 4. Okay, next.
The second strategy is fact families. This strategy is the most commonly used and works when students understand the relationship between addition and subtraction. For example, from the fact families given below, when students sees the subtraction equation 6 minus 2 at the same time 6 minus 2 can also link to the addition equation 2 plus what number equals to 6. For example, 6 minus 2 equals to 4, and so at the same time 2 minus 4 equals to 6. Addition and subtraction has the relationship of fact families. The third strategy is recognizing doubles. In these strategies, we can recognizing the fact families associated with adding doubles. Let's look at the example. In these fact families of the first equation is about the addition. 2 plus 2 equals to 4. So in doubles, we should add 2 doubles and add again another 2 doubles and become 4 doubles. So in mathematics is 2 plus 2 equals to 4. While in second equation of these fact families, that is subtraction, are also the same, but at here is should remove the doubles. So 4 minus 2 means that 4 doubles remove 2 doubles, it will left 2 doubles. So in mathematics is 4 minus 2 equals to 2.
The fourth strategy is the thinking strategy of sames, and this method is used when a number is subtracted from itself. And this will give another generalization that students can quickly identify the answer. For example, 10 minus 10 will equals to 0. So when 10 minus 0, it will equals to itself, which is 10. And here are the diagram that shows that 10 apples minus 10 apples, then there will be 0 apples left. The fifth strategy is subtracting from 10. This is to recognize the fact families for sums to 10. For example, when 14 minus 6, we can do it like 10 minus 6 equals to 4. Then we get a 4 and plus another 4, then we'll get the answer, which is 8. Amy?
Okay, thanks. For the subtracting tens, this is a pattern that students can pick up on very quickly, seeing that the ones digit remains the same. So when the number is 0 at the end, so we can turn it into the word, which is tens. So 70 equal to 7 tenths, so they were more easy to do the subtraction because it only meant the one number. For next, Atira. Then is subtracting 9. The pattern that develops for subtracting 9 can be easily identified by most students. They can quickly subtract 9 from a minuend by adding 1 to the ones digit in the minuend. For example, 17. They will 17 minus 9 equals to 8. When they want to subtracting 9, they will subtract 9 from the minuend by adding 1 at the 7 and subtract 1 at the 10th digit, so it will become 7 plus 1 equal to 8. Okay, next, Atira.
Okay, next, the next thinking strategy for memorizing the fact of subtraction is subtracting numbers with consecutive one digit. So what is consecutive one digit? Okay, consecutive one digit is number that follow each other continuously in one digit. For example, 1, 2, 3, 4, 5, 6, 7, and 9. Okay, this pattern will always result in a difference of 9. Okay, for example, 16 plus 9. Okay, we know that okay, six after the one digit in 16 is 6, and 6 after 6 we see that subtrahend the equation is 7. So 16 6 7. So they always, this pattern always result in difference of 9. So 13 minus 4, 3 4. So 3 4 we get always 9. 5 6 always 9. So I give another example. 20 apa ni? 19. 19 ke? No. All have one digit that are consecutive and the result is always 9. Okay. Okay, next, subtracting number with consecutive even or consecutive odd number digit. So, like I said earlier, consecutive even number that follow each other continuously in even number in one digit. For example, 0, 2, 4, 6, 8. Okay, this pattern will always result in a difference of 10, 8. So 14, we see the one digit in minuend is 4. Subtrahend 6. 4, 6, we always get 8. Okay, second example, 13, 3. 3, minuend in this equation is 3. So 3, 5. This is consecutive odd number. Of 14 minus 16 is consecutive even. So 4, 6 is even. Kalau 3, 5 odd number, odd number lah. Okay, 12 minus 4, 2, 4. We know that 2, 4 is even number. So when we see the equation that have subtract the minuend is 2 or no. When we see the equation that have this 2, 4, we always can get 8. You understand or not? If you guys don't understand, I will repeat again. Okay, that's all. That's all from us. Thank you.
So you guys understand or not? Anyone got any questions? So the presentation was good. I like your book, the way you presented, okay? But I just want to tell you that these strategies are all suggestions. So it is not like you have to use the strategies. Sometimes students have their own strategies, okay? So if the students' strategies work, then it's good. They can use that strategy also, okay? Okay, I think it was okay just now, the subtraction. So the most important thing for subtraction is that we must tell them to think addition and use the fact families, okay? So with that itself, they can answer, they can find all the answers to subtraction facts. So when you use a subtraction chart, make sure it is written here, subtraction. Make sure it's written here, subtraction, okay? And this one here, you must change it, okay? You must put a subtraction. The rest of the chart is the same. Okay, this part here change the addition to subtraction. Okay, so when you do subtraction, like how Wan Jin said just now, we always start from the inside. Say you want to take one number here, 13. Okay, so 13 minus 7 is 6. Okay, that is how you teach them. Okay, or if you take 9 minus 5 is equals to 4. These are the facts. Okay, 9 minus 5 is 4, 9 minus 4 is 5. Okay, the one thing I forgot to tell you just now, that is the commutative principle. Because of the commutative property, like this one, 2 minus 1 is 1, and 2 minus 1 here is 1, or 7 minus 4 is 3, and 7 minus 3 is 4. Because of that, all the facts on this side here, okay, all the facts on the right hand side of this red line, okay, except for the diagonal, is the same as all the facts on the left hand side of the red line. This is commutative principle. That means students memorize all this part is enough already. The other side is just commutative. They just have to turn the facts around. So if we look at the facts on the right hand side of the red line, there are 55 facts here. So actually students only need to memorize 55 facts. The other 45 facts are from commutative principle. Okay, so we have finished with addition and subtraction. Both the groups presented very well. Everything that's important you showed very clearly. Okay, so thank you very much to both these groups. So next we go on to multiplication.
Madam, wait for a while, yeah.
Okay.
Good afternoon to Madam and my fellow friends. Today our group will present the basic facts of multiplication and the thinking strategies. Then next slide. So I need to explain what is the facts of multiplication. Actually, the facts of multiplication is the answer to a multiplication calculator. Let's say 2 times 3 will equal to 6. Then the 6 is multiplication facts, and 2 is multiplier, and 3 is multiplicand. So next slide. And for the multiplication 1 to 9, there was 100 basic facts. Next slide, Jian. So for thinking strategies, we can make the facts concrete with a simple visual to help students for understanding. For example, is dot array. Dot array can help students to relate the connection between Okay, so dot array can show the relationship between addition and multiplication. In this case, we need to prepare a dot array with the 9 times 9 table and a L-shaped color paper. So by using dot array, the L-shaped color paper will be needed to block the parts that we don't want to see it. Let's say we need to see 6 times x. How 6 times x will look like? Then the L-shaped paper will move it and become the second picture at there. Because 6 is the number of groups and 8 is size of the group. So students can count the dot on the table there. So they will see it. They need 6 groups of 8 to get 48. This is also means repeated addition. Then next slide. Jing. Okay, then we go and see the next is basic multiplication fact chart. So we can, as you can see the table there, the teacher can use these charts and out in the classroom so that it can help students to for memorizing the multiplications. Let's say we need to see what is the value of 3 times 4. We need to teach students how to use these fact charts. Let's say 3 times 4, the vertical line in the left is means by multiplier, and the horizontal row, the first horizontal row is meant by multiplicand. Then when we need to see 3 times 4, we need to see the first column of 3, and the 4 is the horizontal row at 4. We need to move to 4. So we call students to see the intersection between these two numbers, which is 12. So students will know 3 times 4 will equal to 12. Then next slide. Jing. Maybe Jing lines was not good now. Okay, then so this basic multiplication fact chart, we can help students to learn it by using chunking method. That which is we need to separate it into 4 sections. As you can see, the section A, students will start by learning the find times table. Then after that, master the part A, then they can go to section B, which is they will learn out to 9 times 5. Then move to section C, which is same way, and the section lastly is section D, learn the 6 times 6 to 9 times 9 chunk. And then after they master all of these, they can practicing by memorize the whole 10 timetables, 9 timetables. Then next slide. And because we can study through this basic multiplication chart, we can also study the patterns. So through the chart, students can notice some of the rules, which is multiplications orders. The multiplication order does not matter. This is also show commutative properties. That means, as you can see, the green color side is actually congruent to the light pink color side. So let's see, we need to see 8 times 2. Then they will see the answer is 16. But when we see from 2 times 8, the answer also 16. This is a commutative property. Then next, I will let Yin continue.
So for now, I will continue to talk about use a rule. 0 facts. When a number is multiplied by 0, the answer is always 0. 1 facts. When a number is multiplied by 1, the number is unchanged. For example, we can look at this picture. 2 groups of 4. You see inside the group have 4 ball in a group, then a second group. So in here have
8 balls. The other group is one group have 4 balls in a group. Then the last is 0 ball. So we can look in words is 2 times x, 2 times 4 equal to 8. 1 times 4 equal to 4. 0 times 4 equal to 0. So that can fix to the facts that I taught just now. So the following thinking strategy is commutativity. Commutativity comes from the word commute, which can define as to move around or travel. According to the commutative properties of multiplication, changing the orders of the numbers we are multiplying does not change the product. It's just like same as the addition and subtraction. For example, 2 times 3 equal to 6. If we change the positions of 3 and 2, become 3 times 2 equal is also 6. So the position changed, but the answer is remain the same. So we look at the second example. 7 times 8 times 11 times 2 is also equal to 11 times 2 times 7 times 8. So the position is changed, but the answer is still remain the same. So now I will pass to my group members.
Now I will explain use tens. Firstly, for tens facts, it will be derived from base 10 knowledge. For example, 6 times 10 equals to 60. Students can use the structure materials, visualize and describe as group of 10 as shown below to get a better understanding. Next. I will pass to my group mate.
Okay, for the next thinking strategy is doubling. Doubling can help with both addition and multiplication. Multiplying by 2, by 4, and by 8 all use doubling strategy. First is multiplying by 2. Instead of thinking 2 groups of 6, student can think that it's double 6. So 6 double will become 12. So 2 times 6 will get the product is 12. Next. For the second one is multiplying by 4. Instead of thinking 4 groups of 6, student can just think double 6. Means 6 double will become 12 and 12 double will become 24. So 4 times 6 will get 24 as the answer. For the third one is multiplying by 8. Instead of thinking 8 groups of 6, student can just think about double 6. So it's the same. 6 double will become 12 and 12 double will become 24 and 24 doubles will become 48. Next. Angie.
Okay, thank you, Angie. Now I will explain the next strategy, which is build-up strategy. So, build-up strategy is a strategy that we can use through part-whole thinking by using the use tens strategy that was explained just now. So we know that use tens strategy is basically just same like the multiple of 10. So if for the build-up strategy example, if we ask to find 12 times 6. So if we didn't memorize the multiplication table, we may not know the answer on the spot. So we can do like this. First, we just think about the nearest multiples of 10 from 12. So 12 to the nearest multiples of 10 will be 10. So 10 times 6 will be 60. So we know that 10 to 12, there is only 2 groups. So since the question asked to find the multiples of 6, so there will be 2 groups of 6. So to find the answer of 12 times 6, we'll just need to use 60 plus 6 plus 6. Since there's 2 groups of 6, so the answer will be 66 plus 6 and the final answer will be 72. So next slide will be build down strategy. This build down strategy is just totally opposite from the build-up strategy. Just now the build-up is like addition, so now the build-down will be subtraction. So if we ask to find 9 times 8, the same steps, we will have to find the nearest multiples of 10 first. So will be 10 times 8 will be 80. So we know that 10 to 9, just one group of 8. So to find the answer, we will just need to use 80 minus 8, then the answer will be 72. That's all from our groups. Thank you.
Okay, okay, thank you for your presentation. Okay, there are some things, just remember that basic facts is within 81, so you cannot go outside of 81, and also we only do multiplication of 2 numbers only, not more than 2 numbers. Okay. Okay, let me just summarize it only. Okay, so we had a few strategies just now. The first strategy that I want to go through is we always start when we want to teach basic facts of multiplication. If you are a teacher, you're teaching basic facts of multiplication. So the first thing that you want to do, you want to put up this chart in the classroom and leave it there for the whole time you're teaching. Okay. So the students must be able to see this chart. These are all the basic facts of multiplication. From here, we can teach them maybe line by line, okay? Okay, say we want to start teaching, we start with the zeros fact, okay? Zeros factor. So that is the use a rule multiplication. That means we tell them that any number, okay, my zero is missing also here in this chart. Okay, so I think I need one more column here, 0. Okay, I need a 0 here and a 0 here, one column here. Okay, so this is 0. Okay, sorry about this. So all this is 0. So we need to tell them that when you're multiplying with 0, you get 0. Okay, so that is a rule. You just have to tell them that, and they have to remember, and they have to know that. And then it is the one rule. That means any number times 1, you get the number itself. Okay, like what they told you just now. So these two we teach first, or we can teach this at the end. Okay, up to you. These 2 is finished. These 2 rows we have taught using the use a rule, that is multiply with 0 and 1. Okay, so after that we can move on to the maybe the 5 facts, use 10 strategy. The use 10 strategy actually means we are actually teaching the 5 facts. This one here, okay? We are teaching all these facts and these facts. We are teaching these facts using a use 10 strategy. It means we are teaching them, say you want to know what is 5 times 4. 5 times 4 is, what is 5 times 4, okay? So to know what is 5 times 4, we think 10 times 4. 10 times 4 is 40. So 5 times 4 is half of that, 20. Okay, so what is 5 times 8? 5 times 8, so we think of 10 times 8. 10 times 8 is 80. So 5 times 8 is half of 80, because 5 is half of 10. So 5 times 8 is half of 80. So that is what we mean by use tens strategy. So this 5 times table, or 5 facts we call it, okay? We can teach using the use tens strategy, because the 5 times is always half of the 10 times. Okay, so we are using 2 strategies here. One is use the rule for 0 and 1, and the other one is use 10 to teach the 5 facts only. Okay, and then we have the doubling strategy. Okay, I think Anji showed you all the card. That's a very good card. That's a very good teaching aid to teach the doubles strategy. Okay, so for doubles strategy, we use doubles strategy or doubling. We use that to teach 3 different facts. We use that for all the 2's facts, all the 4's facts, and all the 8's facts, both ways. Okay, all these in pink, all these facts in pink can be taught using the doubles strategy. Okay, doubles strategy meaning, okay, double strategy meaning if you want to know what is say 3 times 2, 3 times 2 is the, or 2 times 3. 2 times 3, if they give you 3 times 2, you must think 2 times 3. That means 2 times, okay, 2 rows of 3. So you have 2 rows of 3. This is double 3. Okay, this is double 3. Double 3. Okay, you have 2 rows of 3. If you have 4 times 3, then you must think this is 2 double 3. Okay, double 3 means double 3. This is double 3, and we double this whole thing. This whole thing we double again, so we get another set like this. This is called double. Okay, double 3. So actually we must make the cards where we can fold. Okay, we have a folding line here. So first you only show double 3, then you open up and you show double 3. So if you have 8 times 3, 8 is always double. That means we already have double 3. We have double of this. So now we have 4 rows of 3 already. So now we want to double this whole thing. We want to double it. Okay, so we double this whole thing. We get 1, 2, 3, 1, 2, 3. We have 4 rows. Okay, so this whole strategy is called double 3. Double 3. Okay, 8. So 8 means 3 times double. 4 times means double. 2 times is just 1 double. Okay, so these are, you can use cards like this to teach this strategy. Okay, the strategy is actually doubling, but we use cards like this to help us to teach the strategy. Okay, so that means all the 2's facts, 4's facts, 8's facts, we can teach them through doubling. So if it's a 2 facts, they must just think of double the number. If it's a 4 fact, then they must think of doubling the number twice. So if they see the 3 in their mind, they must double that first and then double the whole thing again. So if it's an 8 fact, they must double it once, double it twice, double it 3 times. Okay, so the students must know that 2, 4, and 8 is all related. Okay, it's all related, all just doubling. Okay, okay, so those are the 3. So we finish with 3 strategies. And then we have build up and build down. Okay, build down is for 9 facts. Okay, build down is all the 9 facts we can teach using build down. How do we teach build down for 9 facts? Let's say we have 9 times 3. 9 times 3, you know, is 27. Okay, so we relate this with the 10 facts. We know that 10 times 3 is 30. All right, 10 times 3 is 30. So if we build down, we just minus 3, then we get 27. Okay, so if you want to know 9 times 5, so you think of 10 times 5. 10 times 5 is 50. So 50 build down, minus 5. Minus 5 is 45. That is called build down. Okay, this strategy is very easily taught using some special cards. So when you use those cards, children can see very clearly the relationship between 9 and 10. Okay, so building down strategy is for 9's fact using the 10 tables. Okay, and the last one is building up. Build up is for 6 facts. Okay, this is build up. Build up is for all the 6 facts. We want to teach 6 facts using build up. Okay, so how do we use 6 facts? We say we want to know what is 6 times 3. To know 6 times 3, we relate it to 5 facts, because that's why you must teach the 5s and the 10s. You must teach 0, 1, 5, 10s first before you teach all the other more difficult ones. Okay? 6, 9, all is a bit more difficult. So we teach the common ones first, 0, 1, 5, 10. Once they've learned 0, 1, 5, 10, you can teach the other facts relating to that. Okay? So 6 facts we always relate to the 5 facts. They know that 5 times 3 is 15. So 6 times 3 is built up, one more. Okay? One more, add another 3 here. Okay? So 6 times 3 is 18. If you want to know what is 6 times 4, then you know that 5 times 4 is 20. So another 4 more is 24. Okay? If 6 times 9, if you want to know what is 6 times 9, then you know that 5 times 9 is 45. So 9 more is 54. Okay? So these are built down facts. Okay? And the last turnaround facts, which is the most important thing that students must know, turnaround or commutative. Commutative, or we call them turnarounds. Okay? 3 times 4 equals to 4 times 3. This also a good way of teaching is if you have flashcards like this. 3 times 4 and you have at the back you have 4 2. Yeah, so you show the cards and then turn it around that they have presented. You can use any strategy. The child even have, most children, some children have their own strategies. It is okay to use their own strategies as long as they can memorize and remember all the basic facts. Okay, so you can also use strategies like chunking, like what they told you earlier, chunking and all that. But whatever you do, try to go systematically. Okay, and just to show you some of the teaching aids that are commonly used. Okay, this one Anji already showed you. This one, 2 times 6. This is the doubling cards. Doubling cards. So if you have 2 times 6, actually this one card here we can use to teach 2 facts, 4 facts, and 8 facts. Okay, so you see the card is folded like this at the back here. So we have all the dots at the back here. So when you want to teach the 2 facts, you only show this much only. Okay, and then when you want to teach the 4s and the 8s facts, then you can say 2 times 6, you only show this 2 times 6. And then when you want to show 4 times 6, you open up the card here. You open up to show double 6. Okay, and then when you want to show the 8 facts, there's a fold here, and you open up this card here to show double 6. Okay, this is doubling cards, we call them. These cards are to show use 10 cards. These are use 10 cards. Okay, so you see this is 4 times 10. Okay, we know this is 4 times 10. So if we want 5 times 10, all we have to do is fold the card, fold to the back. You fold to the back, so what is left here is 5 times 4 or 4 times 5. Okay, so if you use 10 cards, so if you want like you want to teach them 5 times 2, so you must have 5 times 2 is also 2 times 5. Okay, so 2 times 5, we want to relate it to 2 times 10, so you must have 2 times 10. 1 2 3 4 10 like this you should have. Okay, then when you want to teach 2 times 5, you just fold this part here to the back. So you know 2 times 10 is 20. So 2 times 5 is half of that is 10 straight away. Okay, so these are the use 10 cards that you can use to teach multiplication. Okay, this one are the build up and build down cards. Okay, so for the 9th fact, we have the build down cards. These are the build down cards. If you want to teach what is 9 times 3 or 3 times 9, if usually it's easier for 9 times 3. So we have 9 rows of 3. So if you have 3 times 9, you ask them to think 9 times 3. Okay, so 9 times 3, you think they already know 10 times 3. So ask them, show them this card. 10 times 3 is 30. They already know that 10 times 3 is 30. So 9 times 3 is 1 less. So you fold the card over. Okay, you fold the last part over, so there are only 9 rows. So 9 times 3 is 27. Straight away, the student can see 3 less. 3 less than 10 times 3. Okay, so these are build down cards. For build up cards, if you want to teach like 6 times 3, you show them 5 times 3. They know that 5 times 3 is already 15 because the 5 times table is very easy for the student to memorize. So they know 5 times 3 is 15. So 6 times 3, just open up one row. From here, you open up the card. Okay, you open up the card. That's why we call it build up. Okay, you open up the card and you see one more row. That means 5 times 3 is 15. So 6 times 3 is plus another 3 more, that's all. So 6 times 3 is 18. So all the 6 facts are, we use the 5 facts to teach them. We use this kind of cards, that's why it's called build up. All the 9 facts, we use the tens tables to teach. We build down, okay? So these are the build down strategy. These cards we use for the build down, okay? So that is for multiplication. Sorry. Okay, so you must know all the 100 basic multiplication facts and you must know how to teach them. All we have so many strategies here. Use tens, doubling, use the rule, build down, build up. And then we have a few more facts that don't fit into the strategies, okay? These are the 7 facts. This you must teach separately. So these are strategies. To help you to teach the strategies, we use things like 10 frames, all these cards here, folding cards, double cards, build down cards, build up cards, concrete materials, okay? All these things are to help you to teach the facts, okay? So what the teachers sometimes do is just teach the multiplication fact in a, you just say it out. But when you teach like this, it helps them to understand. Even if they forget, they can build their own facts again, okay? So when you teach like this, you're teaching them to construct facts, okay? Not just to memorize, but first to understand the concept and construct, and then later they must memorize, okay? Okay, so we can continue now with the last division.
Okay, madam. Okay, so my group, Zulaika, Hazima, Fiza, Natisha and Izzatul will present about basic facts and thinking strategies of division. Okay, what is division? Division is a method of distributing a group of things into equal parts. The main goal of the division is to see how many equal groups or how many in each group when sharing fairly. Okay, we go to basic facts. Okay, we will see this. A sentence of number 36 divided by 4 equals to 9. Okay, so 36 is dividend. It means that 36, a whole number or a sum of number that we want to divide with, we call it as dividend. And then 4 is a divisor, which a number that we want to divide by. Okay, so equals to quotient, where the answer that we get by the division. Okay, so next we will see some important things or important facts about division. First, division means splitting into equal groups. Division is repeated subtraction. And last, division is inverse of multiplication. Okay, we see first, division is repeated subtraction. It means that a whole number or dividend that we want to subtract with divisor repeatedly. For example, 35 divided by 7, we get 5 groups. Okay, for example, we see this way. 35 minus by 5, we get 30. And then we minus 5 again until we minus it 7 times. So 5 is subtracted 7 times to get 0 remainder. So the main thing is that we subtract it until we get 0 remainder. Okay. In sentence way, also like that, we subtract it until we get 0 remainder. So we can see that there are 7 times to subtract with 5. Okay. Same with division way. This is the true way for division lah. The dividend, which is 35, we divide by divisor, which is 5, and then we get the quotient. We get 7 because we already got the remainder 0. Okay, for division is splitting into equal groups. It means that groups of dividend, we split them into equal groups. We get a same quantity. For example, there are 20 students to split into groups. Each group will have 5 students. How many groups will we have? Okay, for example, there are 20 students here, and then we want to separate them equally into 5 groups. So we get for each 5 students, we split them. Each 5 students, we split them, and then until there are no students left. So we get 5 groups. Okay. Okay, last division is inverse of multiplication. It means, for example, 3 times 4 equals to 12. It is same with 12 divided by 4, we get 3. Okay. It's like, for example, the cupcake. For 3 times 4 for multiplication, from we have 4 groups of 3 cupcakes, and then we combine them all in one group. So they have 12 cupcakes. Okay. While division, we have one group of 12 cupcakes, and then we split them equally into 4 groups of 3 cupcakes. So it is the same, but it's just inverse. Okay. For 3 times 4 equals to 12, they give 2 facts of division, which is 12 divided by 4 equals to 3. Same goes to 12 divided by 3, we get 4. Okay, same goes to 12 divided by 4, we get 3. And so the division gives 2 basic, 2 multiplication fact, which is 3 times 4 equals to 12 and 4 times 3 equals to 12. Okay, next Zuleika will present this.
Okay, next is the 100 basic facts of division. First, multiplication chart. A multiplication chart is a table that shows the product of 2 numbers. Usually, one set of numbers is written on the left column, which can be identified as multiplier, and another set is written as the top row, which identified as multiplicand. The products are listed as a rectangular array of numbers. Next slide. Okay, next, how to use multiplication chart for division. First, divisor, the set of a number at the left column used as divisor. For quotient, the quotient is located at the top row. The dividend are listed as a rectangular array of numbers. Next slide. Okay, for example, I choose 20 divided by 4. Step 1, find the divisor which is 4 at the left column. Step 2, go over the 4 to find the dividend which is 20. Step 3, look up from the dividend 20 to the top of the row. The row is where we can get the quotient which is 5. So there is the step we can use this multiplication chart for division.
Okay, next, we are going to present about the thinking strategies. Okay, what are thinking strategy? A thinking strategy is a way to think about a process to arrive efficiently at an answer. For example, for multiplication, like a previous group present just now, the doubling method. Okay, if asked to multiply a number by 2, one could double the number because doubling is a very effective thinking strategy for multiplication facts of 2, 4, and 8. Next. Okay, so the thinking strategies that we are going to explain for division facts is think multiplication, main strategy, and fact families. Okay, now I'm gonna explain about the think multiplication main strategy. Okay, first, anytime a number you divide by 1, the answer is always same as the dividend. For example, if 7 is divided by 1 is equal to 7, which is 7 is the dividend. Next, the divide by 2. If the I'm sorry. Okay, if the last digit in the number is even, then the entire number is the same as cutting something in half. For example, the number 12. We know that the last digit of number 12 is an even number, which is 2. So the number 12 is divisible by 2. Next, divide by 4. If the last 2 digit divide by 4, then the entire number is divisible by 4. For example, we know that the number 1, 4, 2, 3, 7, 7, 3, 2 can be divided evenly by 4 because the last 2 digits, which is 32, is divisible by 4, which is 32 divided by 4 equals to 8. Next. Next, divide by 5. If the number ends in a 5 or a 0, then the number is divisible by 5. For example, like the number 15. Okay, the number is the end of the number is 5, right? So the number is divisible by 5, just like the other number that ends with 0, like 20, 10, 30. It also divisible by 5 because the end of the number is 0. Next, divide by 6. If the rules for divide by 2 and divide by 3 are true, then the number is divisible by 6. Okay, next, divide by 9. If sum of all digits is divisible by 9, then the entire number is divisible by 9. For example, we know that the number 183322145 is divisible by 9 because if we add all the numbers in the numbers, which is 1 plus 8 plus 3 plus 3 plus 2 plus 1 plus 4 plus 5 equals to 27, and 27 is divisible by 9, which is equals to 3. Lastly, divide by 10. If the numbers end in a 0, then it is divisible by 10. For example, 20, 30, 50, any number that ends with 0, then it is divisible by 10.
So before we go to the fact family for the division, we have to know what is the fact family. So what is fact family? A fact family can be defined as a group of matched facts of or equations created using the same sets of numbers. The fact family show the relationships between three numbers involved. For example, the first example, this is for addition and subtraction fact family. A fact family has been created using the number 9, 4, and 5, where 4 and 5 are parts, while 9 is the whole. So you can see the block there where all the parts multiply other and plus one another and get the whole. So for example, the part is 4 and 5, then 4 plus 5 is 9. 9 is the whole. And same goes to the subtraction, where 9 minus 5 is 4, and 9 minus 4 is 5. And next slide, please. Another one. Okay, this is example 2, which is a fact family has been created using the number 12, 4, and 3, where 4 and 3 are parts, while 12 is the whole. This example is for multiplication and division fact family. As you can see at the block, there was two parts, from one on the top and one at the side. And if we multiply or divide the parts, it can produce the whole. Okay, for example, 3 times 4 is 12, while 3 times 12. Okay, and 12 divided by 4 is 3, and 12 divided by 3 is 4. Okay, next slide. Okay, so this is the division facts family. The division facts family is multiplication and division facts that involve the same number of equal size group and total amount form fact families. So for the example, you can see the puzzle, the picture of the puzzle. And the example is using the number 5, 6, and 30. As you can know, 5 times 6 is equal to 30, while 30 divided by 5 is equal to 6. And 30 divided by 6 is equal to 5, and 6 times 5 is 30. So the number is just berulang, and it produces, that's why it's called the fact family. Okay, that's all from us. Thank you.
Okay, very good.